My name is Jakub Kozłowski. I'm a Scala developer at ScalaIO, which is a software company in Poland. And yeah, it's really good to see so many of you here today. So I hope you won't be disappointed by this. So the name of the talk is 7 Sins of a Scala Beginner. There's an asterisk. I will explain it in a short while. But I hope not all of you are beginners, because I think everyone can benefit from this talk. So I'll go through not 7, but actually 5 sins of a Scala beginner, and maybe not always a beginner, simply because there's not much time, and Scala is really an easy language. You don't make that many mistakes, right? Right. But still, I can only talk about 5 today. And before we begin, please advise, remember that there are no silver bullets. So whatever I tell you, whatever anyone tells you that you should or should not do, it's never as easy as never do this, never do that, always do this. So you should always think about the specific use case and be pragmatic about what you're about to do. So let's begin, and we'll go through the sins one by one. So the first one is sacrificing readability for conciseness. And with such a language like Scala that has a lot of features that give you the ability to type less characters, fewer characters, write less code, and have more functionality than in, for example, Java. It's really easy to forget about the readability of our code. So what does it look like when you sacrifice the readability of your code? For example, you might do something like that. You have a map. I don't know if you can see it in the back, but you basically have a map of some values, doesn't matter what, and you want to have a list of the fields, of the keys of that map. You might just use the keys method, but let's imagine this is not just a map, but this is like a list of pairs or whatever. So if you can see, maybe you can't. Let me just zoom in real quick. Better now? Cool. So you see these 2 underscores and 1. And someone who isn't very familiar or is just starting with Scala, they will look at it and be like, what the hell is that? Why are there 2 underscores? And what does it even mean? So in general, this is fine for simple cases, right? If you have a map, you can clearly see what's going on if you're familiar with the syntax. But if you're not, you're going to be puzzled for a while. So why it's bad is because you don't have the context. You don't always have the context. You don't always see what that first value is. That's first of all. And sometimes it's confusing syntax basically. So instead, what you can do is just do a pattern match like this, pass a partial function, and just return the first field. So that way, I think, brings some context, and it's much more readable for newcomers. Another case when you might sacrifice the clean code, the readability for fewer lines of code, is if you have a very long chain of maps, flat maps, and so on. So yeah, let's imagine you see this line. You have map, flat map, filter, group by, and so on. And then 50 characters later, you find .count with some function and +5. So this doesn't really look good, and no one wants to see code like this because, first of all, it's unclear what this line does. You just get some results, and you have like 6 or 7 lambdas on your way. And it's hard to debug because if you want to see the result after each step or any step, you would have to create some additional vals. So if you can't really modify the code quickly, you're gonna have a lot of problems with that. I've been there, and I don't recommend doing that because I didn't write this kind of code. So what you can do instead that will solve these problems is just create some vals in between, name them properly so that they carry some meaning and enable debugging and reading. And one more in this sin. This is basically about skipping the type annotations in public APIs or in in services. And why? At first, this might not seem like a bad idea, because you might be able to see to predict what the type is. However, there are some reasons why you shouldn't always do that, especially with implicits. But let's forget about that for a while. So first of all, the type can leak implementation details of that function, because sometimes you return something too specific, too concrete, and when you change it to something more general, it may turn out that someone was actually depending on the fact that you have some specific implementation, and they were using some methods that the more general type doesn't have, which should be private, by the way, anyways. So what you can do to fix it, obviously, you can add a type annotation with the right level of abstraction. In this case, it's like a future option of user info. Yeah. So a general rule of thumb for using fewer characters or not, if you aren't storing your code on a floppy disk, and if you're not writing a tweet, and if you're not writing Game of Thrones, then you don't need to spare characters to make anyone happy. The tweet part is not very relevant now, but you get the idea. So to sum up, remember that there's this quote, I don't remember by whom, sorry, but it's programs must be written for people to read and only incidentally for machines to execute. And it's actually true, because most of the time when you're spending some time debugging or trying to develop an existing project, a huge project, you're going to spend most of your time, a vast majority of your time, on reading it and not writing any. So it's really important to have your code written in a readable way. So you should always think about how much meaning your code has, and not how many characters you save or lines of code. Now the second sin, I love it. It's feature overuse. So Scala has a lot of cool features, a lot of syntactic sugar, so much that you can get diabetes from it, apparently, like these 331 people. So what does it mean? Let's imagine we have this user service class, and I need to zoom in again. Yeah, I hope you can see it. So it's just a service that has a HTTP client dependency and makes some HTTP calls in its methods. So what's bad about it? I think you can guess. If you can't, well, I need to tell you because we don't have much time for guessing. It's a case class. So why is it a case class? Well, probably the reason is because someone doesn't want to type new every time they create an instance, which is actually in one place in the whole application. And I've seen code like this. So it doesn't really make much sense to make a service like that a case class, because if you don't use like on apply, copy, the direct field access from the external places, and so on. And in this case, it's probably broken anyways, because I think the HTTP client won't have equality defined the way you would like to have it defined either. So what you can do instead is just, in this case, you might just use the apply method, just create your custom apply method in the companion object, or just spend the 4 characters, new and space, to use the constructor directly. And about well, if you just need a case class for access to one field or for an apply method, you might consider doing that manually, but instead of making it a full-blown case class, because, well, it just suggests that you're gonna use at least 1 or 2 of these features if you have a case class. Another thing is infix notation in method calls. So it doesn't really matter what this is here. Basically, it's a web service call, like an HTTP call, done with infix notations. So if you've been writing Scala for long enough, you have probably noticed that infix notation for names that have letters and numbers isn't very readable, and it works way better for symbolic names. So well, this might be controversial, but I think you shouldn't do that for normal names. And you have the postfix notation here as well at the end with the get after a space, and that requires a feature flag import if you don't want compiler warnings. So instead, you should just use the dot notation. Like it's still just as many characters, but different characters, and use the infix notation for symbolic names. Another one, when you use a feature too much, is returning tuples, returning unnamed tuples in specific. So let's imagine we have this extract function somewhere that takes a name string and returns two strings. So can you guess what the two strings are? Well, you might not. I can, but not everyone will. And that is because they might be two copies of the same string. They might be first name, last name, or maybe the other way around. So you never know. So what you can do, well, what's bad about it is that, again, we don't have context, we don't have meaning, and quite importantly, we don't have any type safety because they are arbitrary strings, and there's an unlimited amount of strings. So what you can do about this, at least about a few of these problems, is you can make the function return a tuple of some type aliases. So imagine first name and last name are now type aliases that are equal to string. But when you look at the signature, you can clearly see straight away what the types are, what the values will be. Or you can replace the whole tuple with a type alias for a pair of strings, and it's still better than just returning a tuple of strings. And if you want to go a step further and add some type safety, you can make first and last name a case class. Or you can make first name and last name some value classes, which I think is not a bad idea. Another one. So basically we have a sequence of maps, flat maps again, but this time they're nested and chained, and we have a mixture of these things. So you don't see this kind of code too much, I hope. But if you do, it's really hard to see what... Well, you have a lot of indentation, a lot of nesting, and that's usually a bad thing. So what you can do instead is just use for comprehensions, or sometimes you can use the applicative builder if you have independent computations, but that's a topic for a different talk. Or you can even the simplest solution actually would be to extract some common parts, some parts from this snippet, like the mostly nested lambda, the third line. You could extract that to some named value, some named depth that will still have more meaning than this, and it will still be easier to read. So to sum up, you should always think about readability again, and use the minimal solution for what you're doing currently, which is actually following the principle of least power defined by Lihaui in an article that is linked at the end, which I really recommend reading, and the whole series is amazing. Now my favorite one, the third one, the one about implicits. So you may not know it yet, but implicits are most likely the most abused Scala feature, and I'm going to show you why. So the first case, let's imagine we have this value class, a user ID with an int inside. So pretty cool, we have a value class, we have some more type safety, let's say. Now let's imagine we want an easy way to convert that to an int. So what do? We create an implicit conversion from user ID to int somewhere in the implicit scope, and it works well, and we can easily access the value as an int without any additional code. But now let's imagine we want to create these values in an easy way, create user ID values out of ints, for example, in tests or somewhere else. So we can add a conversion the other way, from int to user ID. And now we basically have a type alias because we have, well, anytime we need an int and pass a user ID, things are going to work, and the other way around as well. So we basically waste code because we might have as well used a type alias for user ID equals int. So what's wrong here? We are missing the point of value classes. And what can we do instead to solve this problem? If you really need a quick way to create user ID instances from ints, you can add an explicit conversion through an implicit class or something like that, and have something like 10.toUserID. So it's still a better thing than just an implicit conversion inside a companion object, for example, that will be visible everywhere, and it's gonna cause a lot of headaches. Or you can actually use the second implicit conversion, but maybe just in tests. It's still not a bad idea. Another case of abusing implicits would be with implicit conversions again. So what you can do wrong about conversions is, well, this one that does string to int can throw some exception in runtime, and also brings some confusion if you do it by accident. So I'm gonna rush a bit here because I don't have much time left. So I think you should avoid implicit conversions as much as possible, unless you really have a good reason to use them, because implicit classes and parameters should be enough for you anyway. Another case, implicit parameters. So if you can see, it's a method with an implicit parameter of type list of string. So what is tricky about this is that list is actually a conversion from int to string in this case, because from the index to the values. So a dangerous conversion is brought to our implicit scope. And if you do something like this, create a list with 2 values and say, I want a string, but I use the value 2, it's going to be implicitly converted to the string through a list, through a list apply, and you're going to end up with an index out of bounds exception, which I think is nothing you would expect. So, oh yeah, and using a type like list, which is a standard library type, also makes finding the implicit instance you have used harder. So it's not really friendly for debugging. So again, I think you should avoid implicits of standard or common types. Standard like in the standard library and common like in common libraries. Unless it's obviously a type class or something like that. So monad of list is fine, but list of HTTP header, not really. And if you really want to pass around an implicit list of something, you can just wrap it in a value class and you'll have just that. Or come up with some clever ADT. This one is basically the same with default parameters. It's pure evil and it really makes debugging a pain. You know what kind of pain, but I can't say it. So to solve that problem, just see the previous point. So to sum up, implicits are a very powerful feature, and you should always think about the consequence of using it, because of with great power comes great responsibility. So the fourth thing is trying to outsmart the language, but I don't have much time for that. Let's just skip it. Long story short, don't reinvent the wheel and see if the standard library isn't written in a better way than you think. For example, make string is actually implemented with string builders and not some immutable functional fashion. So it's actually pretty performant, and there was someone who did it by hand. Anyways, so things like premature optimization and writing custom wrappers over some libraries like drivers for Mongo and so on, which I have seen in production code. You should avoid that, and you should focus on your business logic. And it deserves its own talk, definitely. So if you don't really need ultra performance, if you don't see a bottleneck somewhere, please don't reinvent the wheel. And yeah, see how the standard library is implemented. So now the last one, I hope I can tell you a bit about it, is writing Java in Scala, which I think has been mentioned plenty of times here already. So it basically boils down to writing imperative code and ignoring the power of this type system. For a second, let's forget what happened after this GIF. So what does it mean to write Java in Scala? It's basically using nulls and exceptions in your production code. And why is that bad? Why is that a bad idea? Because in Scala, nulls are not explicit enough, and neither are exceptions. They are just dangerous and can cause headaches and problems and crashes and potentially loss of billions of dollars in runtime. So why else? Because we have our own tools to handle nulls and exceptions. We have option, either, try, and validate it from cats or ScalaZ, and so on. So you should use these error handling and nullability wrappers to handle these cases where you normally use nulls and exceptions. That's a better way, I think. Actually, in Scala we don't have that yet, but in Kotlin, for example, you have just nullable types, which are like options, but with less syntactic overhead. What else can go wrong? We can use mutable state and side effects. And I'm not saying that you should avoid all side effects, because that way you'd end up with Haskell. And this is Scala, not Haskell. So why it's bad if you have multiple state and side effects everywhere? It makes your code harder to reason about, harder to understand. And I think someone said it's the new spaghetti code today. And it makes debugging an internal pain. If you have a sequence of mutations on some value, yeah, I don't wish this kind of debugging to anyone, to the worst enemies. So what you can do to not to have these kind of problems, you can basically limit the scope of mutability as much as possible. Just try to limit it to the smallest method or function that you have, if you really need it. And if you need it, it's probably for performance, which you probably don't need in this place. You can just use like folds, options, many things you can do in Scala. And for effects, you can use more explicit effect types like IO, the IO monad or the free monad. But let's be honest, nobody does that in production, almost nobody. So at least please try to use future, because it at least is a sign that there are some effects inside, and probably you don't do any effects outside of futures anyways. So future is fine. So another thing, stubbornly sticking to object-oriented patterns, which are not always applicable, especially in the functional world. So I'm not gonna talk about it more now, but you should focus on functional patterns first. And only if you feel like it, use object-oriented patterns. And now the last one, my favorite, from writing Java in Scala, the return keyword. And I think you should never use the return keyword, because it silently throws an exception underneath, which is caught and then used in some magical voodoo way. And it's an effect. It's a side effect that shouldn't be there. I've actually seen snippets like option something, get or else return none. And if you see that line, you might think, okay, get or else none, fine. But no, it actually returned from the whole method in a very, very weird way. And I don't think you should do that ever. So instead, just use find, fold, if else, because that's what you basically usually do when you mean return. So to sum up, how to avoid writing Java in Scala: just learn the language features, just learn the language and the frameworks, the CATS or ScalaZ libraries, and don't write Java. This is Scala, not Java. And please use safe error handling techniques. You're gonna thank me for that, and thank everyone who contributed to them in the future, and conform to the principles of functional programming by writing pure and safe code. And now practice, learn, and do that for the rest of your life. So to sum everything up, some of these mistakes that you might make don't apply only to Scala. They apply to all the development you do ever. And syntax and features of a language are just the beginning of your journey. This is something you learn at the beginning and not the end. Then you have to do some practice. You have to learn how to write good code with the tools that you have. And remember that you should never stop learning, because yeah, that's all the fun, right? So if you want some more knowledge about good Scala, you can check out this article, the first one, and the whole series. A talk by my friend, High Quality Scala from Day One, and the book Pragmatic Programmer, which I recommend to every developer, not just Scala or backend. So thank you for coming. I hope you have some questions. You can ask me later or now if we have time. Do we have time? No, we don't. So you can just catch me around and ask some questions or email me. The slides are here, and you can contact me on Twitter, email, or something else on my website. Thank you for coming, and enjoy the rest of the conference.